Hello, and welcome to today's stream. So I noticed that people watch these streams even after I've done the stream. So um, I don't intend on talking about everything I'm doing because that would imply that there's like people are actively listening. But the way these streams work is, first of all, I don't have a regular streaming schedule, so um, usually people don't know when I'm going to stream, which means very people are around to like tune in or even match it with their schedule. So um, I usually don't have a lot of talking within the streams. I just work on the thing I want to work on. But since I noticed that people watch the streams past me doing the actual live, what I'm going to do is I'm going to momentarily, after a certain duration, kind of try and explain what I'm doing. But I won't be talking throughout the stream because I made a shift where I'm doing things that I'm not familiar with. So most of the time I'm learning something. So you can't explain what you don't know. So that's why I kind of minimize the yapping, if you may. So I'll be running sort of like a timer in the background, and then after a certain duration, I'll do like a recap of what I've done. And in that recap, I can maybe have some explanation of like what I'm doing, and also make it rewatch worthy. So that if somebody is watching this after the live, they can probably gain something, if anything. Yeah, because YouTube keeps this after the stream has ended, and people bumping into them and trying to watch them as regular YouTube videos. And basically, I'm not talking throughout the entire video, so it makes it really somewhat awkward. Hence the idea. So if I'm quiet, just know that I'm doing what I wanted to do, and then after a while, I'll do a recap of like what I've just done or I've just changed. So something about this particular series, I have multiple ideas for stuff I want to live stream, but on this one, the main overall goal is to build like a simulator, which is something completely new to me. I don't have a game development background, so I don't primarily do game development, so this is totally new. But then underlying that is also the choice of technology for building this is something that I primarily use for iOS development and things for the Apple ecosystem, which means that comes with a lot of tooling. So building software that's not really targeted for Apple ecosystem, things like iOS, watchOS, iPadOS, macOS, requires a bit of a shift on what Swift the language actually provides in terms of tooling, in terms of libraries, and most importantly in terms of interoperability. Because another thing I'm trying to do is to look into how well the C and Swift interop works, and how seamless you can move things between Swift to like a C library, and how you can retrieve data based on like C language, a definition of data types into Swift. So, and that means you're able to use most C libraries with Swift. So that's what I'm also experimenting with and seeing how far that capability can be pushed. And this can open doors for later on if I want to use various C or C++ libraries for shipping software, mainly because of the additional performance advantages and the additional efficiency that comes with something low level like C or C++. So that's the main goal, is to, at the end of the day, have a governance simulator. But the secondary goal is to learn more Swift development that's not targeted, not mainly targeted towards Apple ecosystem development, and more towards something that would run on maybe Linux or Windows, God forbid, or something, some other platform, and that's not necessarily kind of targeting Mac OS, iOS, or WatchOS, or any of those platforms that initially Swift was built to, the language and the ecosystem is built towards targeting, and get that C++ interoperability with Swift, so that you get kind of the safety that comes with the working with a language like Swift, and also the performance and speed that you'd get from C by utilizing some of those native libraries. Yeah, so that is the idea. The general structure of the SIEM is, it should be, I want like a long running background mutation of particular metrics. I don't know if mutation is the right word, maybe change of particular metrics that determine the state of the SIEM, the simulator, at certain times, and then have user input change the variables that determine the state of that simulator, and maybe go as far as randomizing events by maybe bringing in some algorithms such as Monte Carlo, and such that you have these randomness to how the simulator works, but it's controlled randomness, because the influence of whatever user input enters the simulation is weighted, and also the effect of that user input is randomized, so it's not predictable. So if a user does a particular action, on the other side, it's not always going to be the same effect. So if a user sends in a value like 1, you won't always get 0 on the other side. Instead, that 1 can result in 0, it can result in 1, it can result in 0.5, whichever range we end up setting up for the simulation. So I want a simulation where user input influences the internals of the simulation, but not in a predictable manner, because in real life, things are not predictable. You might do something that leads to some effect, but the same thing in a different environment, different variables, might lead to different effect. So yes, that's what I'm doing. So currently, the main task that I have is integrating with SQLite for persistence, and I'm integrating with SQLite so that I can set up the foundational metrics and initialization data. So you have some data that creates the start state, or the initial state for the simulation. So that state, of course, will change in the lifetime of the simulation, but you have some foundational initial data that kickstarts the simulation, because the simulation should be able to run even without user input. So it should be like its own self-sustaining system. But when you get user input, the user input runs through some algorithms that introduces weights, applies weights, and introduces some randomness, and then that randomness then affects the state of the simulation moving forward, not just at that instance. So currently I'm just trying to see how I can have that persistence layer using SQLite, but I don't want to use an ORM. So I don't want to have like a wrapper around SQLite. Usually that's how most platforms give you ways to interact with SQLite. There's an object relational mapping wrapper, and then you can use that wrapper to kind of indirectly communicate with the underlying C SQLite library. So what I'm trying to do is to have the raw C SQLite library. There's a build that's available that has the C SQLite lib compiled and made available for use with Swift. So this just takes what's called the amalgamation of the C SQLite library, which is taking the whole library, putting it in a single single file, and then compiling it. So that makes it easier to integrate. So there's a GitHub project that has done this. So with that, then you get like a Swift package that you can pull into your Swift project, and you can start interacting directly with the C interface that comes with the C SQLite library, or the SQLite library. Yeah, so that is what I'm doing. I wrote an initial implementation. Basically, it's just a test, a Swift test. And what I'm trying to discover here is how does Swift pointers and C level pointers interact. So if I'm passing a pointer to a function, a SQLite function written in C, how would I represent that pointer in my Swift code? So Swift has this like 4 or 5 variations of pointers and how those pointers work. There's opaque pointer, there's unsafe mutable pointer, there's additional pointer types, and each of them try to map to some form of the underlying C pointer. Yeah, so that's the path of discovery that I'm doing. So when I wrote this the first time, obviously it didn't work because this is fairly new to me. So basically, this function is just meant to attempt to open a SQLite database and just open a database and get a zero signal, which is usually SQLite, okay, and see if we are able to, number one, generate a SQLite database file, because SQLite is a file-based database, and then see whether we can actually link to that SQLite file, and later on try to see whether we can execute queries like the schema definition and the procedural actions such as CRUD operations, create, read, update, delete. So this failed, and today the first thing I'm going to do is to try and update it, see where I've made mistakes, and see whether I can get it to work. So once I get it to work, I'll try and have an implementation of that on the actual code. So the actual production code right now just has this hello world function, so there's nothing there. So if things work out in the test, then I'll write something here and hopefully have a matching test for that as well. But this is just to experiment with the library first before I start writing any production code. Yeah, so the way I'll run the timer, and I hope this, usually there's a default Google timer that's available, and usually the streams go for like an hour or more sometimes, but usually I end this after 1 hour. So I'm thinking maybe I do like maybe I do like 20 minutes. Maybe that's long. Maybe I can I could do 20 minutes. I think 20 minutes is fair. And after 20 minutes, I'll probably try and explain. 20 minutes seems really long. Maybe 10, which I think I can get with this. So 10 minutes. and then I try and explain what I'm doing. So we've gotten to a point where the database initialization test passes, and that means we can now move on to actually doing database transactions. But maybe I can do a recap first. So the mistakes that the other function had was one important thing, and this is something I learned after writing it in the previous stream, was if you open a scope, let me just get the diff. So when you're working with the pointers in Swift, you can create a closure that allows you to work with that pointer safely without potential memory corruption and the other unsafe behavior that comes with working with pointers. So after that closure ends, that pointer is either you free it yourself, like in the case where we were closing the database, because the database is an opaque pointer, it's a pointer on its own. So when we reach out to SQLite to close the database, what SQLite does is that it clears the memory that was used by that instance of a SQLite database connection, and whatever memory was allocated for interacting with SQLite at that time, either through the SQLite object or through things like prepared statements, are cleared for you by the library. So back in Swift, we've created a pointer to SQLite, multiple pointers in this case, for the name and the SQLite object, and later on when we are doing database transactions, the actual SQL queries will be pointers that we are passing down to SQLite. So those have to be cleared. So when you create a closure, like in the case where we are using something like with unsafe pointer, in fact, I could probably just get to GitHub and open the old version of this code. Let's see. So I can increase that font a little bit. So at this point where we're creating with unsafe buffer pointer, so this allows us to take this file, which is a string, and you know, C strings, the string, or the variable that indicates the string usually just points to the starting point of the character array that forms that string. So you need a pointer to the first character that forms the array, and then while reading the string, C will iterate over the next pointer until it reaches a null terminated value, which is represented by -0. So when we are passing strings from Swift to C, because we are communicating with C, we have to kind of use the language that C understands, that is pointers. So we'll be passing the pointer to the first character of the string. And what I expect is behind the scenes, Swift will pass the rest of the character array that forms this string through this contiguous array of C characters. And what C will be able to do was find the first character and then run through the remaining array until it reaches the null termination, or the termination. So the main mistake here was that once you open a closure with a call such as this, there's multiple variants. But for example, when we use with unsafe buffer pointer, which unwraps and gives us a pointer that we use with C, that pointer is no longer available in the global scope or the rest of the function. It's no longer available to the rest of the function should the lead database this whole other scope. So if we go ahead and use this DB file to call SQLite 3 open database connection on line 28, this value is now a dangling, it's either a dangling pointer or it has been automatically cleared by Swift. So it's no longer available to us to use. So that was the main mistake that was there. If you modify something within here, then it won't be available. Because by the time, so here we are passing a reference to the pointer to DB file and expecting that will be available here. But what actually happens is that this pointer is cleared once you exit this scope, and when you pass a value to it, it will just be a dangling pointer, which is actually very quote unquote dangerous, I think, because it is pointing to something that doesn't exist. This is cleared immediately you exit this scope. So that was the main mistake I was doing last time. The other minor mistake I was doing was when opening a database connection, the open create has to be passed with another flag, which is just good. So you have to pass them in as a pair. That was just passing one, because my intention was I just want to open a database connection. I don't intend to do any reading or writing. I just want to test that I can actually open a database connection from Swift, calling the C API to like open the database connection. So I was just passing one flag, which is SQLite open, but I was actually supposed to pass them in a pair. And the pair is so SQLite open create. Open create is essentially ensures that if the database file doesn't already exist, one will be created for us that we can use. So this is important for, especially in a test case. So I expect to run it multiple times. So once I execute it, I expect the database file will be created if it doesn't already exist. If you're sure the file is already there, then you don't need to pass this flag. Then read write is the other flag that tells the database that yes, open and create the file if it doesn't exist, but also this particular quote unquote transaction, or the set of transactions that will follow this that will be performed on this SQLite object will include both reading and writing to the database. There's variants for read only and write. So this is read write, which is the one we're using here, but there's also a variant for read only that you can pass in when you just want to read value. So that's one thing I was missing. So in this new version, that's what main thing I changed by putting the open SQLite 3 open function within the closure here. Means that the pointer we are granted from the database file name, so the pointer that we are granted, we are able to pass it down to SQLite and use it. So we no longer need this pointer out of this scope. Once we exit this scope, we no longer need this particular pointer, because the purpose was just to open a database connection, which is to update this opaque pointer that contains the actual SQLite 3 database object. And with the database object, you can use it to now later on to like perform a database transaction. So that's still available on a global scope. The other change was adding this defer block. So this tells Swift to execute whatever is inside here once this whole function finishes executing. And what we're doing is just ensuring that that database connection is closed. I was hoping to have access to the testing macros that come with the Swift test, like require, but since they are throwable functions, we're not able to use them in a defer block. So I'm not able to assert or verify anything within the defer block. So that means we have to rely on logging to kind of know that everything is working. One last change I made was, and this is just a safety thing, was to check that SQLite 3 actually passed a valid pointer before I try to print the error message. So If it passed something else that was not a valid pointer or a null pointer or whatever, then this scope, this block would not be executed. So, and you can also do that with guard statements, but iflet also does the trick. And also, since we are doing some initialization there, I think it fits using iflet. And then at the end, this is not a change, we're just checking this open state that we receive after calling SQLite reopen. And this can be various status codes. SQLite OK, which is status code 0, tells us that the database connection was opened, or the connection to the SQLite file database was established, and now this DB opaque pointer is available for use, so you can do stuff with it. Yeah, that's so that's the main change. So at least we've gotten to a point where I know how to establish a connection to the SQLite database file through the C API from Swift. So from Swift to the C interface that's provided with SQLite, and then down to the actual SQLite database file. And now you can do interesting things with this database file, like doing the initial schema, which is my next stop. So I'm also thinking perhaps within the production code, I should have an entity that is responsible for opening a connection to SQLite. And depending on how things go with the concurrency, I could have a situation where I open a database connection and give the database object, use it within a transaction, and get rid of it, basically clear it. And anytime any part of the program wants to communicate with SQLite, it has to get its own database object, use that database object, and once it's done with it, it's responsible for clearing that database object. Which, of course, working in Swift, also, if you forget, once the function that you're executing in closes, the scope within that database object file is sort of out of scope, then Swift's automatic reference counting, IRC, will kick in and clear that pointer for you. So that means you are less likely to have a lot of dangling or orphan SQLite objects floating within your program as it executes. So things like memory leaks and stuff like that will be limited. So my next plan after this is to have whatever we have here established on the production code base in an entity. It can be an actor, it can be a struct, it can be a class, but have it established, and then have a test, of course, to verify that that component works well. And then once that's done, then I can move to the actual database transaction. The main thing is establishing the schema and the initial data, which is the main goal of this particular task. So I'll do that in the next few minutes and see how far that goes. The other thing is, I'm wondering whether I can clear the database file. So once this test executes, we end up with the DB file here, GovSimDB. So from Swift, I should have a way of deleting this DB file. Having it here is nice because you can access it with the SQLite 3 CLI functions. Like I'll do that, and I can check the schema, which right now is empty. So knowing where the file is nice. But after each test, I want that file cleared. Except I've never done file IO with the Swift outside the iOS or macOS ecosystem, where you're using the built-in APIs that are provided by Apple for interacting with the file system. In a plain Swift project, this will be super new to me. So I'll also check out how that works, because I don't want this file to be floating around after every test. So once the test executes, I want that file removed so that it doesn't outlive the test itself. So let me get some of those tasks done and then see. A few things have been achieved. Most importantly, I've been able to move the logic for obtaining a database, a SQLite database object to the production code away from the tests, and through this function, which essentially just replicates what was achieved with this particular test function. So the few changes: one, the caller of this function can pass in the flags, and the flags can be in which state do they want to open create the database object. So if you're opening SQLite just to read a value, so that flag can be passed by the caller, or if they're opening SQLite to write values, they can pass that flag. Stuff like open create can be passed in by the caller of the function. So if we assume I'm making this call deep inside the simulation code where I'm sure the database connection was already opened, I don't need to call open create. So I can just call in read only if I just want to extract a value, or read write if I expect to add new values to the database based on the object that's passed from here. The other thing I'm doing here is I'm using a Swift result object. So this allows you to basically have like an abstraction of the state of the result of the function. So if the function fails, you can return a failure state. If the function succeeds, you can return a success state plus the underlying return value for the function. So it's a good way for making the state or the outcome of the function more explicit, so that if a caller wants to see whether the function succeeded before they try to work with the value that comes from the function, they're able to do that. So with this result object, if this function executes successfully, then we expect an opaque pointer, but it's still nullable because it's a pointer. I don't want to unwrap it before I pass it to the caller. Also, if the caller is going to make subsequent calls to SQLite, they're going to need to pass a nullable pointer, so there's no need unwrapping it. And of course, it returns an error if any error occurred. In this case, I'm utilizing SQLite 3 error message API. So if that returns an error message, then we return with a failure state. If it doesn't return, okay, so this SQLite 3 error message is notorious for returning a no error state if there's no error that occurred. So it's good that we are first checking whether open state returned SQLite OK, which is status code 0. So if we get SQLite OK when we're trying to open the database, we don't even need to interrogate SQLite 3 error message, so we don't need to call that. So here you can just return a success state with the underlying opaque pointer. And if open state is not SQLite OK, then we can go ahead and unwrap the actual error message. If we get the error message, we pass it in by converting the C string into a regular Swift string with this constructor in string. And if we are not able to determine the error message from SQLite, we can just tell the caller that we failed to open a DB connection and non error, and then pass in the open state code. So open state will always return a status code, and maybe the caller can do further investigation to kind of see what that status code represent. And and executing the test, I've seen that the test passes, which means we have that capability within the production code. So now universally there is a function that we can call to obtain a SQLite object, and then we can run transactions with that SQLite object. So the natural place to go with this after this point is to do the schema, do the underlying schema for SQLite used to initialize the database, and then with the underlying schema we also try and later on, in fact, within the schema initialization, we can create the initial objects, but first of all, we need a schema. So I'm wondering whether to do that now or to push it to later, since at least some goal has been achieved here. The stream is already 1 hour in, which I think 1 hour is good enough. I don't need to stretch it. So I'll just commit the code, and on the next stream, I'll work on establishing the schema for the database. And with the schema, I'll be able to initialize I have the initial state of the simulation, and then now I can work on the actual simulation code once this database layer is properly established. So I'll end the strip there. If you're watching this later, you can find all source code on the related GitHub account, sorry, GitHub repository, and that is this repository here. So this is where I'll be having all the source code. Something new. So this is where the source code is. So I'll just commit what I've done, and then I need a function for removing this gavsimdb. I think I'll also write that in the next stream. Now I can add it to gitignore, just in case gitignore. Just in case I miss it. I think it's gavsimdb. Let me write test again, run the test again, and for sure we'll have it here, gavsimdb, and should be added to, yeah. So yeah, it will wait, new file. Okay, I guess I have to remove it first, do a commit, and then in the subsequent calls to git add and git commit, that value will not be included. So let me just see, ignore gavsimdb. Yeah. So and I'll close it there. Yeah, see you on the next stream.